In this video, I'm going to talk about the use of StatCrunch software to solve two sample proportions. I'm going to look at question number 4 in your homework. So I'm going to click on question 4. It says a study was conducted to determine the proportion of people who dream in black and white instead of color. So in population 1, among 310 people over the age of 55, 63 dream in black and white. In population 2, among 287 people under the age of 25, 10 dream in black and white. We're going to use an alpha level of 0.01 to test the claim that the proportion of people over 55, that would be group 1, who dream in black and white is greater than the proportion of those under 25. So proportion 1 is greater than proportion 2 would be our claim. Now that's going to be an alternative hypothesis, so the null hypothesis would be that proportion 1 is equal to proportion 2. And that appears to be answer choice E would be the correct answer choice then. The second step is to calculate the test statistic, and we're going to do this using the StatCrunch software. As soon as we get confirmation that our first answer was correct. All right, so the test statistic we're looking for is a z-statistic. So we're going to click on Question Help at the top right. We're going to click on StatCrunch. It'll open up a new window for us in the software called StatCrunch. And we're going to go to Stat, and we're going to look at proportion stats for two samples. Now, the information we have is not the original data, but it's a summary of the data. So we're going to click with Summary. So in our population 1, we had 63 people out of 310 that said they dreamed in black and white. And out of population 2, we had 10 people out of 287 that said they dreamed in black and white. Our null hypothesis was that P1 is equal to P2. So if we subtract P2 from both sides, we'd get P1 minus P2 equals to 0. Our alternative was that P1 is bigger than P2. So again, subtracting P2 from both sides, we get P1 minus P2 is bigger than 0. And we'll compute, and it will give us a test statistic z that is 6.2744997. We'll also go ahead and give us a p-value for that test statistic that is less than 0.0001, a very small p-value. So now we'll return to the question and enter in our z test statistic. They only want 2 decimals, so we'll put in 6.27. Get an answer confirmed. And then the p-value, they want 3 decimals, so that's 0.000, because our p-value is 0.0001. All right, so our conclusion, since the p is low, p-value is less than the significance level, so we will reject the null hypothesis when the p is low. All right, the phrase to remember is, if p is low, the null must go. So since we're rejecting the null hypothesis, that means we do have evidence to support our claim. So there is sufficient evidence to support the claim. Remember, the claim this time ended up being our alternative hypothesis, because we claimed that population 1 was more than population 2. We're going to confirm that. Now, part B asks for a 98% confidence interval. So we can return to StatCrunch and get our 98% confidence interval. So I'm going to go to Question Help, StatCrunch. If it returns the same information that we put in before, take me to StatCrunch? Let's see. Maybe I need to minimize my existing screen and go back to the StatCrunch that was already opened. Try it again. Yeah, that's what it was. We already had a StatCrunch open. So this is the StatCrunch that gave us our Z statistic and p-value. All I have to do to get a confidence interval is go to Options, Edit. Instead of performing a hypothesis test now, I can click the button for a confidence interval. We were asked for a 98% confidence interval, so I'll change the level there and compute. And you'll see the lower limit and upper limit here on the right for the confidence interval. So the lower limit is 0.1095525. The upper limit is 0.2272127. Now I'll return to the homework question. Oops. I want to return to what I was looking at. Let's shrink that. Yeah, get back to our homework question. Too many windows sometimes. Alright, so the lower limit, they only want 3 decimal places, so I'll type in 0.110. And the upper limit is 0.227. Now, the confidence limits don't include 0. If they did, then 0 could be the true difference between the two groups. But since it doesn't include 0, that means that the groups are not equal. Because the confidence limits include only positive values, that means that P1 has to be bigger than P2 at all times. So that means population 1 is greater than population 2. Part C asks for an explanation of the results of why people over 55 grew up or might see black and white more often. They're saying they grew up watching black and white television. Can we use those results to verify the explanation? Well, that's the explanation that they grew up watching black and white might be a reason, but statistics won't verify that reason. Statistics only speaks to whether or not the claim that we made or the hypotheses that we did is true, not why it's true. Let's see, so the correct response is the results cannot be used to verify the cause of the difference. So statistical results can be used to show that there is a difference, but not necessarily why there's a difference.